Let's continue our study of DNS. This time we're going to focus on primary and secondary zones in addition to caching only. So we'll label this subsection primary and secondary zones, which is the primary implementation or most common implementation of DNS. So the features include ability to service zones, which means you service records within those zones. When clients consult your DNS server, you are able to authoritatively speak on behalf of a zone. So 2, authoritative support for a zone. So we're going to create as our task, our first task, a zone, an internal zone, named linuxcbt.internal, which currently exists and is hosted by our 75.100 system. So we'll just mimic that zone and show you the files that need to be modified. Now first and foremost, as step A, we'll modify etcname.conf to include the new zone. Then we'll create the corresponding zone files, or in this case zone file. Once done, we'll restart named and test resolution of DNS primary zone. And then the next task will be to create a slave server. A slave server is also a secondary server, and test the ability to replicate records from the primary to the secondary. So let's follow through the steps. We'll modify etcname.conf. It currently has zones defined, and with this version of named, we have to update the appropriate view for internal versus external. So if you scroll down through the document, you'll see that there's a view defined for internal resolution in addition to localhost resolution. You want to define your zone in the internal zone if it's an internal zone that should not be shared with outside hosts. So somewhere within the internal zone, we'll need to define, or the internal view that is, we need to define our linuxcbt.internal zone. So we'll copy the definition here that's set up for the zone my.ddns.internal.zone and paste it into our documentation using Control-V. So we want to update this to reflect linuxcbt.internal as our zone. Its type, since it's a primary server, is master. Currently we'll allow no updates, but we could indicate an IP address of a secondary server. And the file will be located instead of beneath the slaves directory as indicated by this particular entry for my.ddns internal.zone, we'll simply reference the file name as linuxcbt.internal. So let's change this from slaves followed by the directory name to linuxcbt.internal, optionally .db since it is a database. And this is all relative, if you recall, to the var named directory. So this is where primary zones are kept. Secondary zones are kept in the slaves subdirectory. So let's go ahead and nano again etcname.conf and navigate to the area where we copied the item from my DDNS, and get ready to paste in our new item. So we need to indicate the file where it's located and then terminate the descriptor or the definition of the zone using a curly brace, a right curly brace, and a semicolon, which we have set up. We'll just remove the commented line and we'll be set to go. So this is the zone definition as far as named.conf is concerned for linuxcbt.internal. The fact that it's a master server that references a database file which we've yet to create. So we'll paste this in here. We can include a comment if we'd like. Otherwise, just paste it in enough, allow for enough tabs, and here's our comment. First internal zone. Save the changes. Then we need to create a file in var named which stores the zone records. So we need to create the corresponding zone file. Now there are example files here. If we take a look at any of these files, we'll see example entries such as named.local, for example. This is a perfectly fine reverse file. It contains a pointer record. However, we need a forward instead of a reverse lookup file. For that, we can use my.internal.zone.db. So let's cat the contents of this file to see what it returns. And it is empty, no records defined. Let's cat localhost.zone, and this is appropriated. It's got an IPv6 as well as IPv4 record. So let's copy localhost.zone to linuxcbt.internal.db, as that's how it's referenced in the etcname.conf file. Then we'll modify it, and we'll need to include the appropriate records. Now, the @ wherever you see it indicated within a zone file name, represents the full name of the domain. So long as it references a zone as it's described in etcname.conf and you're happy with that, no need to change it. Otherwise, you can indicate the full domain, linuxcbt.internal, for example. The name server is set to @, but again, this can be updated to be an explicit IP address of a name server or an A record of a server. We've got an A record, which is for the host, and a quad A record for IPv6 resolution. Again, for the source of authority, we can be more specific. Instead of simply indicating @, we can indicate the name of the server that will function as a source of authority. This server's name is linuxcbt.serve4.linuxcbt.internal. And the email address of the administrator of the zone is root.linuxcbtserve4.linuxcbt.internal. Let's just ensure that this is correct. We'll bring it all on one line, and that takes care of the source of authority record. As far as the name server is concerned, again, you can indicate the name server explicitly using @, which references the domain which we'll need to have an entry for, or explicitly as follows: linuxcbtserve4, followed by the domain suffix, followed by a dot to terminate the line. And if you have other name servers for this zone, go ahead and specify it. Otherwise, this will suffice. So that's a name server record. How about just general A records? Well, we can begin by creating one for linuxcbtserve4 that's required. Internet record A, and its IP address is 192.168.75.199. Again, we have an IPv6 record. It's not necessary a quad A record, so we'll remove it. So we've got one host defined. If we also have a mail server, let's say that the primary server is the mail server. Its type is MX, and its priority is 10, followed by a full name of linuxcbtserve4, followed by the full name dot. And then below we define the hosts, including, and this is the first host defined, so we'll paste it, including the DNS server itself, as well as optional servers defined within linuxcbt.internal. We've been communicating thus far with linuxcbtserve4 as well as linuxcbtserve1, which will be sure to note, which has an IP address located at 168.75.10. These are the two systems we were working with primarily, but there's also linuxcbt media 1, which is currently a DNS server, so we'll include it as well, and its address is .100. So slowly but surely we're building a proper zone file. This zone will have a TTL of 86,400 seconds or a full day, unless each record has a TTL. To reduce the TTL to something that updates much quicker, change the global TTL, let's say to 3,600 or even 600 seconds. This will be the global TTL that applies to all of the embedded records, unless of course you indicate a distinct TTL as follows: 3,600 for the linuxcbtserve4 record, but 600 for the remaining records. So in every DNS file you'll find a source of authority record which references the server that's responsible for the zone, followed by an email address for the responsible administrator for the zone, followed by directives regarding the serial number of the zone, the refresh rate, retry, expiry, and minimum values for retrying the zone synchronization. And it is customary to set the serial number to a value that's equivalent to the current date. So that's 2008-01-22 with a revision number of, let's say, 01. And we'll just bump this revision number up with each change. So this is a proper zone file, and we've completed as a consequence, unless we run into errors, step B, which is to create the corresponding zone file. So let's save the changes and return to the shell. Just ensure that the permissions match the other items. And notice that all the files are owned by root, at least the files, not directories, including linuxcbt.internal.db, so this is fine. Our zone's defined, and it's owned by root, and when we restart the named instance, we should be able to then perform a query of the forward lookup zone, the primary zone, linuxcbt.internal. Let's kill the server using kill all named, then a psef grep named will reveal that it's been killed. Then we'll go ahead and execute service named start, and this will cause name to start. And then from a remote system, since we're using views, we'll attempt to query the local system. Let's try it from linuxcbt serve1 using dig at 192.168.75.199 for any of the records defined in the zone file for linuxcbt.internal, such as linuxcbt serve4 dot the fully qualified domain name path. And there we see the server has responded with the answer for linuxcbt serve4 with an address of 199. Let's try looking up another host, and it responds there as well. Let's also insert some generic records that we'll find on internet-facing servers such as www and mail. We'll set our mail server or our www server to be 75.199, and this is an excellent opportunity to define a CNAME record. We could using mail, for example, and point it to linuxcbt serve4 linuxcbt.internal. So these are more of your traditional record types. Mail, www. Let's also define a CNAME for FTP. Pointing it to the same system. And notice when we create the CNAME record, we terminate the fully qualified domain name with a dot. That's the standard CNAME record type creation rule, that you terminate it with a dot. Let's save the changes. In fact, we need to update the serial number. This is good practice. So we'll move this to 2. And the serial number, again, is used by remote named daemons to make a determination regarding whether or not their version of the zone is out of date. So if an 02 version is detected by a remote system that has an 01 version on file, the remote system will know, the remote named instance that is, will know that it has an outdated copy of the zone file. Refresh, retry, and expiry all pertain to the slave servers as well for this given zone. So these slave servers that synchronize with this server will be sure to refresh every 3 hours. And if for some reason the remote server is unable to contact our primary server, then it will retry every 15 minutes. After 1 week of serving stale information, the remote or secondary server or slave server will expire the zone unless it's received within the 1 week period updated zone information. So with that said, let's save the changes with the new serial number. We'll kill all, named, then restart it using service, using exclamation service, clear screen, and then perform a dig from the remote system. We'll look this time for FTP. It resolves as a CNAME record with a time to live of 3600, cross-referencing Linux CBT Serve 4. Let's also confirm that www resolves. And it does. It is in fact an A record and works as expected. Let's look up mail as well, which is a URL that can be used to access mail. We've yet to set up a mail, but we'll look at it later on. So our records are in place. Our server is a primary server, and we've yet to set up a secondary server, but we've confirmed primary access. Our server is also still a caching-only server. If we cat etc resolve conf, we see that our local, or 199 is our local DNS server. So if we were to dig msn.com, for example, the 199 system responds by looking it up through 100 and returning the results of the remote server. So we're still operating in caching-only mode. Now we should just note regarding caching only, which was the first mode that we set up the DNS server in, and that is, there is a package which implements the caching only feature of DNS. So note, install caching only, and we'll take you to the RPM repository. Let's close this tab and navigate to the middle tab and search for caching-name server. This package will set up a caching-only name server. So install it if that's indeed what you're interested in. So install caching name server star for caching-only DNS server. However, if you need a full-fledged DNS server which supports caching-only, forwarding, primary, and secondary services, then install what we've installed, which is the primary bind package, without the additional caching name server. The caching name server package provides the name.conf that's conducive for looking up name server entries or DNS entries on the net, or to allow the DNS server to function as a caching only server. Now how about creating a slave or secondary server? To do so, we need to ensure that bind is installed on a slave system. Slave system may or may not be a Red Hat system. It's up to you. But just ensure that it's installed. So we'll RPM query all grep ibind, and if it is not, we will use yum to do so momentarily, and then update the name.conf to reflect a slave zone. So it's not installed. We'll yum y install bind. This will get it going, and we'll list the steps as yum y install bind. And once prepared, we'll set up the zone files as we've done with the views that are auto-configured, as we did with the primary server. So we'll copy the files as we did. Let's scroll up, and you'll see in our DNS talk that we copied from the user shared doc location all of the items to etc as well as var named. So on the remote system, now that it's installed, let's navigate into user shared doc, bind version, sample, etc, and copy these files over. We could make things simpler by copying the files from the local or from the Linux CBT Serve 4 system, the primary zone, or we could start over. Either or works. For example, from the remote system in named, we can copy all of these files over to the remote system. Let's go ahead and scp star. That'll get everything minus the directories over to 192.168.75.10 to the equivalent directory var named. This will prompt us for authentication. and momentarily we'll copy the files over. Ditto for the slaves subdirectory, whatever's in here can be copied as well. Again, you don't necessarily need these various zones. We're just copying the sample files included with the default Red Hat build. If you don't intend to support dynamic DNS, then don't copy the files. But it just makes it easy if we copy the sample files included. And also in etc, let's scp-name.conf. And in fact, we'll just copy named everything to the remote system, etc. So we've copied the files, and back on the remote system, we may now take a look at named.conf from etc, not from the sample directory, where we'll find the Linux CBT zone, or Linux CBT.internal zone. We'll change the type to slave, so in our documentation, let's be sure as the next step, copy sample files from primary server to secondary server, or from the documentation directory tree. C, modify etcname.conf and set the zone to slave. And by doing so, we'll have to indicate the IP address of the master server. So type will now become slave. The file is also the same, so we'll create an identical file locally, but we need the directive masters. Masters allows you to specify the IP address of the master server for this zone. And as most directives are indicated in between curly braces or the ellipse, which is terminated by a semicolon, will include the IP address of the master server, which will also be terminated by a semicolon, which is 192.168.75.199. So this tells named that there's a zone for which it is to be considered a slave server, and it's going to store the details of this information in the Linux cbt.internal.db file. It's also common to store the file in the slaves subdirectory to show that files that are in this directory are considered slave zones or DDNS zones. But if you wanted to, you could store your zone files in a different directory, so long as named has the permissions, both with SELinux and standard Linux legacy permissions, to write to the directory in which you'd like to store the zone file. You should have no trouble, little to no trouble. With that said, let's save the changes. And we have avoided, as a result of copying the configuration file, having to disable anything related to DDNS keys or TSEC or any security features. And now name.conf has been updated, so we need to get an instance started. This server will become a caching only, as well as a secondary server for the zone Linux cbt.internal once we've started it, and we'll confirm that it's able to query the remote server or the master server for the zone Linux cbt.internal using the dig utility. So with that said, let's start the named daemon using service named start. This will load the various zones. So we've modified it. And D, start named service using service named start. And for E, or for the next step, we should ensure that the named service starts whenever the system reboots using checkconfig. So checkconfig 3.5 named on. And we'll follow that up with a checkconfig list named to be sure that it will start when the system reboots. So named is running, a psef grep named will reveal as such. And then we'll dig from the remote system Linux CBT Serv 4 to Linux CBT Serv 1. Dig at 192.168.75.10 any of the records defined in the hosted zone. And there you see the query has executed successfully. We should also update the primary or master server's version of the file to include the new name server. So update var named linuxcbt.internal.db to reflect new name server. Let's find the window on the primary, which is this system, and we'll nano var named linuxcbt internal db. We'll move the serial number up by 1 and include a new name server line using Control-K, Control-U to paste, and the new server is linuxcbt serve1, for which we already have an A record, so there's nothing else for us to do. Let's save the changes and restart named. We'll kill all, named, psef grep named, and then service named start. PSEF again shows that it's running, and then on the remote system we should see, let's navigate into var named. Let's navigate into slaves. We should see that the linuxcbt internal file has been updated. And there we see it has been. It has the latest serial number, 03, and it also has the new record for the new name server. So we've got 2 name servers defined. So the files are being, or the slave file is being updated by virtue of the slave relationship. Now, as it currently stands, there are no security measures in place to ensure that other rogue or other non-authoritative DNS servers synchronize our DNS information, which is why in the security section we'll lock down the replication process, the primary to secondary replication process. So we've set up primary, secondary, and again, either server can play the role of primary or secondary. Simply define the zone. Let's set up our next task to do exactly that. Create a primary zone on the quote-unquote secondary server. There's really no such thing as a secondary server with DNS, but there is, however, a server that functions as a secondary zone holder. So, on this secondary server, we'll create a zone for linuxcbt.external. Once that's in place, we'll then replicate it to what is considered to be the primary server. Let's navigate to the remote system, or in this case the local system, linuxcbt serve1. We'll navigate to etc and then modify name.conf. We'll navigate to the linuxcbt.com section, .internal section that is. We'll cut this entire block, then paste it twice, making changes to the second instance. We'll label this second internal zone, but in this case, instead of being slave, we'll be the master, and instead of referencing a masters or master, one or more masters, we'll simply comment the line out and change the directory from slaves to just var named and change the file name from internal to external. But before we restart name, we'll copy the internal file to the external file and then just make some minor changes. So name.conf has been updated. And let's just double check one other thing. We've omitted one item, and that is the name of the zone. They should not be duplicated. Now name.conf has been updated. So the first thing is create a zone for linuxcbt.internal in etc name.conf. Second step, copy/create linuxcbt.external.db zone file. So you can create it from scratch, or copy and paste items off the web, or from your existing DNS servers, or just copy an existing file. So on this server we'll copy linuxcbt.internal.db. This came over from the original copy to external. We'll then modify the external file changing wherever we find internal, so you can use your search or replace feature of your editor to make this a quick process, or make the changes one at a time, as we're doing here. So wherever internal is referenced, we now reference external. And the same records will suffice. Save the changes, and now we have a zone file for linuxcbt.external. So on this host, if we attempt to restart the named daemon, it'll restart with a new zone. Using service named restart will cause the new zone to load. We'll psef grep named, it's running, and now let's query it from a remote system such as serve4 to be sure that it's serving records from the external zone, the linuxcbt.external zone, as opposed to, or in addition to, the internal zone. We'll use dig at 192.168.75.10 www.linuxcbt.external, and it should resolve, and there it does. Ditto for internal. Perfect. And it shows the list of name servers. Now, we have not set up linuxcbt serve 4 to replicate the information. So our next step is to set up 4 to be a slave for the zone linuxcbt.external. So to do so, again, we'll modify etc name.conf. We'll find the area which contains linuxcbt.internal, cut the entire block using Control-K and then Control-U to paste. We'll relabel this comment, just to be consistent, as second, but instead of type master, this now becomes type slave. The file name changes, the zone name changes from in to X, and we need to reference masters or one or more server which contains the master zone information, and that's 192.168.75.10, terminated by a semicolon. Now linuxcbt serve 4, after we restarted named, will function as a slave server. In fact, let's just keep with convention by ensuring that the slave file is stored within the slaves subdirectory. So that'll be stored in slaves /. And then we'll restart the name service. We'll kill all named, psef grep I name to be sure it's no longer running, then service named start. Echo of the exit status, it looks clean. Let's navigate now to var named slaves, where we'll see the linuxcbt external file, and if we cat the contents, we'll see it includes various items. This means that from the remote system, if we perform a dig as a client would at 192.168.75.199 for www.linuxcbt.external, it'll work. And there you have it. So we've set up primary and secondary between the two hosts. Again, we have two systems that we're working with, a VMware instance, which is referenced by this physical system, a SUSE box running a Red Hat VMware instance known as linuxcbt serve 4. We've also got linuxcbt serve 1, which is a standalone box, both running Red Hat Enterprise 5, both functioning as primary as well as secondary DNS servers for two different domains, linuxcbt.internal as well as linuxcbt.external.